Hello, everybody, and welcome back to BioSC 140 Human Physiology. This is the video for the JALR assignment number 2. So I'm going to be assuming that you've all watched the first video and have completed the first JALR assignment. With that being said, this one is about hypotheses and data. Analyzing data, displaying data, communicating data to other people. So, assignment for this first section. This particular assignment asks you to read, discuss, analyze, and comprehend the introduction of an article that we used last time, the adipocyte one. This time, you'll be looking for the experimental question that the authors are attempting to answer. What is the question? What is the question that they are trying to answer? Why did they do this experiment? What do they want to know? Why did they do this experiment? What do they want to know? While there are potentially multiple experimental questions, when I do this, this is my 8th semester, I think I probably have gotten as many different answers as there are students. So there's not one clear-cut correct answer. There's different ways to word it, different questions. Know that while writing yours. But the best you can, there's a few different questions they're looking at, and there's different ways to kind of word it. After that, try to find the experimental hypothesis. So start with what are they trying to answer? What is the question? Here is the paper again, or the introduction. And once again, it's delaying a little bit with me scrolling down. All right, so down here at the bottom of the first page, you can put your experimental question. Next up, I want you to come up with a hypothesis for this paper and then a hypothesis for the experiment that you have chosen to write up for your lab report. Now, we're going to take hypotheses to the next level. This is one of the single most important parts of really this whole JARL series of assignments is the hypothesis. I want you to read this page 2 word for word at least one time, preferably 2 or 3 times. So I want your hypothesis to be in a very specific form, because having your hypothesis in this specific form helps you understand this experiment, but also if you get into research, having a hypothesis in this form helps you design an experiment. Usually researchers, they have a hypothesis and then they develop an experiment to test that hypothesis. Having a hypothesis in this form helps a researcher develop protocols that will actually test what they want to know. So here's the general form. If I do this, then this will happen because of this. So if I put ice in a water bath, for instance, then what will happen in that water bath because of this? If I season my steak tonight, then it will taste better because salt will make the flavor of the steak appear better. I don't know. So basically, this form will help you write a rock solid hypothesis. If I do this, then this will happen because of this. I want you to use that exact form. I want to see the word if, and then you do this. Basically the methods. Basically, if you do this, it's basically if, you do the method section. Then this will happen, the expected results, because the proposed why for why you think you're going to get those results. It really explains why down here this form works well. So it's if I do this, so if the methods part, then this will happen, the results part, because of this, basically the discussion part of the paper. All right, if you have any questions on the experimental question or hypotheses, please let me know. Do a good job on your hypotheses for your experiment in this assignment, because your lab report, you need to have a good hypothesis, and I'll be checking all of your hypotheses when I grade these, and I'll let you know if your hypothesis could be improved upon. The most common reason that people miss points on their laboratory report are formatting errors. The second most common reason that people miss points on their final laboratory report is they have something wrong with their hypothesis, and it's usually they didn't use the correct format. So do a good job on this, and you can transfer it directly into your lab report. The next part is about data. In this part, students tend to do a really good job on it. In scientific papers, usually in like the main write-up, they'll have like graphs and diagrams, like easy to digest forms of their data. And then they'll have appendices, or basically in the back, they'll have all their raw data. Let's look at what's on the screen right now. With a quick glance, can you tell anything about monthly average atmospheric CO2 measured at the Mauna Loa Observatory? No, it's a big wall of data. It doesn't tell you anything at a quick glance. So while you should have these in the back of scientific papers that you write, it's not going to quickly communicate or show what you want it to. And that's why we have graphs. Does this down here do a better job? Yeah, this line graph down here does a great job at showing how CO2 levels have consistently gone up since the 1960s. So that's why graphical displays of your data are very important. It's because they communicate information. And for your experiment, you are going to include some graphs, some visual representations of your data in your laboratory report. If you want to get full credit, you are. And I want you to choose the graphical representation that best communicates your data. The graphical representation that best communicates your data, whether that's a line graph or a bar graph or a pie chart, whatever works best for your specific experiment, what communicates the information the best. Down here for this assignment, we're going to look at a few different graphs. And students tend to do pretty well with this part. It's pretty self-explanatory. You're going to read these different questions, and you're going to answer with either A, true, B, probably true, C, insufficient evidence, D, probably false, or E, false. And this probably true or true and probably false or false is what tends to throw students off. If something is true, the data alone are sufficient to show the statement is true. You can look at the graph, you can look at the data, and you can say, yes, this is true for sure. Probably true is different because the data supports the statement, but it doesn't specifically show it. So let's take, for instance, right here, it shows ambient temperatures up to 40. If the question asks about an ambient temperature at 100 degrees, we might be able to infer things from this graph, but we don't have specific data at 100 degrees Celsius. So we can say things are probably true at 100 degrees Celsius, but we can't say for sure. So we could say probably true about something at 100 degrees Celsius. We can't say definitely true. Does that make sense? And conversely, we can say something's definitely false if it's within the data set, within the range that we have. Probably false is going to be like something that falls outside of our specific data set. If you have any questions on it, please reach out to me. But students usually do a pretty good job of getting this and understanding it. Moving down. So down here, I want you to do your visual representation for your experiment, for your data, for your experiment. Now, some students get thrown off because some of our experiments are fairly simple and have 1, 2, or 3 data points. That's all right. I understand that. Some of your line graphs, some of your bar graphs might just have 2 bars, 2 pieces of data. That's fine. I also understand that we didn't do these experiments live. We haven't actually performed them. That's fine. There is experimental data, supplement data, example data in the lab supplement for all of these experiments. Please use that example data. And here's your checklist. Make sure you get everything on this checklist done and submit it on Canvas. If you have any questions, please reach out to me. Have a great day.